How far is far really? Why interstellar distances break human brains. In my last video, I talked about why no alien has ever visited Earth. One of the reasons I mentioned, almost in passing, was distance, the sheer mind-crushing scale of space, but I glossed over it, because to really explain it properly, you need an entire video. This is that video. Because here's the truth. Human beings are completely, fundamentally, neurologically unequipped to understand how far away things in space actually are. We evolved to understand distances we can walk, maybe distances we can drive, at a stretch, distances we can fly. We did not evolve to understand light years, and that gap between what our brains can picture and what space actually is might be the single most important idea you need to understand, the Fermi paradox, the search for alien life, and everything that comes after. So let's fix that. Right now. Let's start somewhere familiar, our own solar system. The Sun is about 150 million kilometers from Earth. That sounds enormous. But let's make it human scale. If you drove a car at motorway speed, say 70 miles per hour, non-stop, day and night, no fuel stops, no sleep, how long would it take to reach the Sun? About 150 years. So you'd die several times over if we had that kind of time. But okay, that's just the Sun. We know that. The Sun is close, cosmically speaking. What about the edge of our solar system? Neptune, the farthest proper planet, that same car journey, 4,500 years. You'd have needed to set off when the ancient Egyptians were building the pyramids, and you'd be arriving now. And we haven't even left our own solar system yet. The nearest star to our Sun is Proxima Centauri, 4.2 light years away. A light year is the distance light travels in 1 year. And light moves at 300,000 kilometers per second. In 1 second, light travels 7.5 times around the entire Earth. So, 4.2 light years, how far is that in kilometers? About 40 trillion kilometers. 40 trillion kilometers. That number means nothing to our brains. So let's use the car again, driving at 70 miles per hour, non-stop, to Proxima Centauri. 37 million years. 37 million years ago, our ancestors were small, monkey-like creatures with no concept of tools, fire or wheels. That's the drive to our nearest neighbour. But okay, cars are slow. What about our fastest spacecraft? The fastest human-made object ever launched was the Parker Solar Probe, briefly clocked at around 690,000 kilometers per hour. That is extraordinarily fast by human standards. At that speed, the journey to Proxima Centauri would take roughly 6,300 years. 6,300 years. You'd have set off before the birth of Christ, before the Roman Empire, before written language existed in Britain. And you still wouldn't be there. And Proxima Centauri is the nearest star. Our galaxy, the Milky Way, contains somewhere between 200 and 400 billion stars. Not millions, billions, stretched across a disk roughly 100,000 light-years wide. Let's scale that down so our brains can cope. Imagine the entire Milky Way galaxy shrunk down to the size of the United Kingdom. At that scale, the whole UK, Scotland to Cornwall, Wales to Norfolk, that's our galaxy. Our entire solar system, the Sun, all 8 planets, everything, would be smaller than a grain of sand, sitting just south of London, roughly where Croydon is. Proxima Centauri, our nearest neighbour, would be another grain of sand, about 2 millimeters away. The centre of the galaxy would be in central Scotland. The far edge would be off the coast of Ireland, and between each of those grains of sand, nothing, just empty space. The universe is not full of stuff. The universe is almost entirely nothing, with tiny, unimaginably distant islands of matter scattered through it. Now, let's imagine an alien civilization exists somewhere in our galaxy. Let's be generous. Let's say they're only 1,000 light-years away. That's actually quite close, in galactic terms. There are roughly 14 million stars within 1,000 light-years of Earth. To visit us, they'd need to cross 1,000 light-years, even travelling at 10% of the speed of light, which would require energy outputs we cannot currently imagine. That journey takes 10,000 years. 10,000 years. They'd need a civilization so stable, so committed to a single mission, that it survives unchanged across a time span, longer than all of recorded human history. Twice over. And here's the thing that really gets me. They wouldn't be travelling to the Earth they observed, because light takes time to travel. The image of Earth they saw when they decided to visit, that's what Earth looked like 1,000 years ago. They'd be navigating to a destination that no longer exists as they picture it. It's like getting on a plane to visit a friend, and they moved house 1,000 years before you landed. I know what some of you are thinking. What about warp drive? Wormholes? Faster than light travel? Look, I love Star Trek as much as anyone, but here's where we have to be honest. Faster than light travel almost certainly violates the laws of physics as we currently understand them. Einstein's special relativity doesn't just suggest FTL travel is difficult. It suggests it may be fundamentally impossible, that the universe has a built-in speed limit, and nothing with mass can reach it, let alone exceed it. Wormholes exist as mathematical solutions in general relativity, but there is zero evidence any natural wormhole exists, and a traversable wormhole would require exotic matter with negative energy density, something we have never observed and may not exist. Could future physics overturn all of this? Possibly. Science has been wrong before, but we should build our understanding of the universe on what we know, not on what we hope. So here's where we are. The nearest star is 6,300 years away at our fastest speed. The galaxy is 100,000 light-years wide. There are hundreds of billions of stars in it, and between all of them, almost nothing but empty space. This isn't depressing. I actually find it extraordinary, because it means that if any civilization has ever managed to cross these distances, even once, they would represent something almost incomprehensibly advanced. A level of science and engineering so far beyond us, they might as well be gods. And yet, the universe is 13.8 billion years old. There are 2 trillion galaxies in it. If life exists anywhere else at all, and statistically it seems almost impossible that it doesn't, then somewhere out there, something has had an enormous head start on us. Which raises the question I'm going to tackle in my next video. If the universe is this big, this old, and almost certainly teeming with the ingredients for life, where is everybody? That's the Fermi paradox, and it might be the most important question the human race has ever asked. See you in the next one.